Hey guys, today I want to do an LCM, GCF, and distributive property review. We've got this fun little robot friend here, so we're looking for a name for him. If you have any ideas, you can post them on Google Classroom. Just remember they need to be real and appropriate, and then we can maybe name our little mascot in this video. So I'm going to be using word problems for this review because that makes it a little bit more challenging, and I noticed that we just need a little bit more review in this. So if you look up here at this problem, it says, Carrie has 12 apples and 14 oranges. She wants to put an equal number of apples and oranges in each basket. How many baskets can she make? Now there's a reason why I worded it, how many baskets can she make? I know I'm going to be taking these two numbers and I'm going to be splitting them up evenly. So I know that I'm going to be finding GCF for 12 and 14. What's difficult is some of you guys might have thought I would have asked how many fruits can go in each basket. Well, the difference with that kind of question is we would just be, you could say, okay, you could put 2 apples and 2 oranges in each basket and then you'll have 2 oranges left over. That's not what this is asking. When it's finding GCF, it's saying you don't want anything remaining. However, it does not necessarily mean that there needs to be the exact same number of apples and oranges together. Like each basket does not need 6 apples and 6 oranges. So let's kind of go ahead and find the GCF of 12 and 14. I'm going to use my bobsled method because it's my personal favorite. If you don't like bobsled method and this confuses you and you want more help with finding different ways like prime factorization, please comment on Google Classroom and I will make sure to poll you on Tuesday. I know that both 12 and 14 can both be evenly divided by 2. 12 divided by 2 equals 6. 14 divided by 2 equals 7. So now I look at my remaining numbers, which are right here, and I think, are there any other factors that they have in common? And there are no other factors that 6 and 7 have in common besides 1. And as I've said a million times before, we don't ever want to factor out 1 because 1 is a factor of every single number. So it really gets you nowhere. So I'm trying to find GCF. I know it's going to be over there on the left is whatever factors they have in common, which means Carrie would make 2 baskets and it would have 6 apples in each basket and 7 oranges in each basket. When you're finding GCF, it does not mean you have to have the exact same number of apples to oranges. It's just asking you to split them up evenly so each basket has this same amount. It'd be like giving you guys candy bags. I'm not going to put 5 gummy bears and 16 suckers in each bag. I can split them up so you get a different number of bubble gum and suckers or whatever. So that's going to be a little bit hard on some of these word problems. But the big thing is when you're looking for GCF, you're going to be taking 2 values and splitting them up by the common factor. So if you're splitting up, you're going to be finding GCF. So let's try a new problem. This says Claire has a book club every 24 days and a pool party every 18 days. After how many days will she have both a book club and a pool party? So for this particular word problem, I'm trying to find when 24 and 18 will meet. If I'm trying to find when 2 numbers meet again, I'm going to be looking for the LCM. I still do the exact same procedure. I'm going to do my bobsled method where I've got 24 and 18, and I'm going to be simplifying them, dividing them by their common factors. 24 and 18 are both even, so I'm going to start with 2. 24 divided by 2 is 12. 18 divided by 2 is 9. Now I need to look at where my remainders are. 12 and 9 have a common factor of 3. 12 divided by 3 equals 4, and 9 divided by 3 equals 3. Now I'm looking at my remainders again to see if I can keep going, and I cannot. 4 and 3 do not share any common factors. Now the difference here is I'm finding the least common multiple. When I'm finding the least common multiple, I'm going to multiply together all their common factors and their remainders. So I want to do 2 times 3 times 4 times 3. When I do that, I get an answer of 72. So to answer my question, after how many days will she have both a book club and a pool party, it would be after 72 days. In other words, every 72 days, she's going to have a book club and a pool party. In problems like this, it could even give you a date and might tell you when she had the last day where she had both, and it might ask you to find the next day she'll have both. And in that kind of case, you want to whip out a calendar, and you could use the calendar to count the amount of days, and you could actually give the exact date. So the first thing I want to talk about when we're reviewing distributive property are some misconceptions that I've seen you guys have, okay? So for example, let's say that I had the problem 24 plus 48. What I saw in some of your quizzes is you took this, you kept the first factor, but you split up the 48. You might have done 40 plus 24 times 8. This is incorrect, and here is why. This is an addition problem, and you made it into a multiplication problem. You cannot do that. So if you're trying to find the distributive property, you cannot just decompose in an addition problem. You cannot just decompose one of the numbers. What you can do is take out a common factor that both 24 and 48 share. So 24 and 48 both share a factor of 12. So I might take out a factor of 12. When I take out this factor of 12, that means I'm dividing both of those factors by 12. 24 divided by 12 is 2, plus 48 divided by 12 is 4. So I simplified this addition problem to 12 parentheses 2 plus 4. This you can do. This would be correct. So remember, distribute means to give. So if I had a problem such as 2 parentheses 12 plus 5, if I was going to use the distributive property to write an equivalent expression, I could give or distribute this outside factor to both terms inside the parentheses. Another way of writing that could be 2 times 12 plus 2 times 5. Remember, whatever sign is in there, that's what's going to go in between the two different sets of parentheses that you distribute that outside factor to. If it was subtraction, it would have been subtraction. Another equivalent expression for this could have just been 24 plus 10. Or you could have even solved it and said, okay, the whole answer is 34. All four of these expressions and numbers are going to equal 34 no matter which way you write it, thanks to the property, the distributive property, okay? So remember, distribute means to give. You're giving anything outside to everything inside. You could also reverse that, and you could take an expression, an addition or subtraction expression, and you could take out a common factor. It's kind of like reversing the distributive property. So it's very, very important that you understand when you can use the distributive property, because you might not be able to if the factors don't have anything in common. But it's very important to remember that distribute means to give, or you're taking out that common factor. So our little robot friend thinks that they understood it a lot better now with that little bit of review and looking at some misconceptions that Miss Greathouse saw. Do you get it? I want you to prove it in your 5-question homework assignment.